oh, the little toy model managed to translate the German sentence, which is a correct translation. So it's not correct in all cases, but it's getting there. And you can train this system yourself. You can do this yourself in a reasonable amount of time. So that's really awesome to me. And the decoder is controlled by this configuration file. So once you get it producing output, you can change some of the parameters and explore what really makes a good translation. And you can specify this in the file or in the command line. So if you have this little toy model working, then, and this is a toy model again, this is on the lower amount of data. You can train this up in 20 minutes or so, and it should run right out of the box. And so you can really play around with it and see what really influences statistical translation. So let's see. So that's the toy model, that once you get Moses up and running, compiled, then you want to download this data to just do some tests and explore a little. So some initial projects that I've done that are sort of exciting is you can build a translation system using the parallel corpora of your choice. You can try the European Parliament data, or you can try some translations of the same novel or text, or your favorite user manual, maybe even, which would output some funny translation. So just experiment with that, and note the influence of the size on the translation quality, or the domain. Well, it trains on any domain. If you train it on a very specific domain, then you're going to end up with translations specific to that domain. So next steps, I'm going to put these slides online so you can sort of check these out as you explore. But try some different things, lowercase the source and the target, adjust the hyperparameters, add a dictionary. You would think that would be automatic, but even a bilingual dictionary can give a few score points, and add some new features to the phrase table. So here are some resources. These are lots of sources of parallel data, or you can just think on your own, instruction manuals, War and Peace, whatever. And here are some software resources, most importantly Moses, which I'm talking about. But there's also a scoring tool for machine translation evaluation, and Giza++, which is a training tool for some of the basis of the theory behind Moses. Mainly Moses uses it to align words so that it can actually discover from the parallel corpora the phrases that should align to each other. So Giza++ contains algorithms that actually align those phrases. So here are some references, and I'm going to close with that. So today we went over some of the history of machine translation, different approaches to it, but really concentrated on the theory and practice behind statistical machine translation. And I gave you a little introduction to Moses, which is an open source decoder incorporating all the theory and practice of state-of-the-art statistical machine translation in the field, and you should be able to just go to SourceForge, check that module out, run the demo, and play around with it, and even do some silly things. I've seen some silly translation engines on the web, maybe translating from, I don't know, rap speak to English or stuff like that. You can do that on your own if you want to make a little silly toy system like that, or you can do something more serious, like really improve translation quality by maybe implementing a new heuristic or something like that. So I'd like to thank you, and if there are any questions, feel free to ask me, and I'll either answer them or direct you to someone who can better answer your questions. Thanks.
So with the factorial stuff, does that handle context sensitivity? Do you just break it down into linguistic units by sentence? Or if I use a phrase in an improbable way in one sentence, does that affect the translation? If I use it again in the next sentence, it's likely to be the same thing, or do you not parse on that level?
It depends on the data that you're using. If you're using factored translation data, if you use it in an improbable manner, the probability there is going to be very, very low. But if you have very good evaluation metrics, if you're evaluating things very well, it will notice if a subset of your translations are scoring very poorly. So it does incorporate that information, but in more of a statistical manner. So if you're using it in a brand new way, no one's ever used I'm verbing your noun in your fridge, whatever. If you're using I'm in your fridge eating your foods, if you've seen that internet meme. If you're using a verb as a noun and it's never been used that way before, then your translation is still going to be improbable. But it's improbable in our minds, I think, linguistically as well. And that's why the word has multiple components. You're not just basing your translation on the part of speech, you're also basing on the source form. So now that I'm in your fridge eating your foods or whatever is very common on the internet, then if you're using that as your data source, then you will start to improve your translation quality. Thank you.
Hi, so I'm just thinking about the problem that some things are expressed in a different way in different languages and phrases don't actually have the same structure.
Yes.
So you used the example of I'm hungry in Spanish.
Yeah.
And in Spanish, as in German and as in some other Romance languages also, it's to have hunger.
Yes.
In English, we have to be hungry.
Yes.
In some languages like Latin, there's a verb to be hungry as opposed to have or to be.
Yeah.
So those don't have the same structure. So I'm wondering, you could say they have the same structure in some sense. I'm wondering what you would need in corpora in order to be able to correctly translate that for a wide variety of persons or tenses or whatever.
You just need a lot of data. So to begin with, it's pretty easy if you're not using a very inflected language. If there's just two forms of the verb, then you've probably seen all forms of the phrase, I am hungry, you are hungry, we are hungry. If it's a very inflected language, and we actually did research with Moses in a very inflected language, Czech, where it has a lot of different forms of the verb, just adding more data improves translation quality directly, and incorporating information about the part of speech, representing language as a vector instead of just trying to translate one phrase to another. So you can, in Spanish, yo tengo hambre, I am hungry. You see those in a parallel corpora aligned often together, so you can do that very easily. If there are 20 forms of the verb to have in Spanish, then that's where you would run in a little problem with that naive method. But that's why Moses is now incorporating information about the part of speech. So if you know that if it's a first person singular, it often translates one way, and if it's a second person plural, it translates another, then you can now incorporate that information.
So you could potentially go from, even if you haven't seen it in the third person, you could potentially go from hat Hunger to he is hungry.
Yes,
even if
exactly.
You haven't seen it in that person.
With the factor-based model, not with the previous state-of-the-art, which was not using factors. It could only do that if it had seen it before. But with factors, you can generalize. You can say, often when I see it this way, it adds on an OS at the end or something like that. So that's one of the novel improvements that Moses offers.
Cool, thanks.
Not all corpora are publicly available, but the ones I linked are. And particularly the European Parliament data is publicly available. And that'll cover you for a lot of European languages. So I listed a lot of data sources, but there are a number of corpora that are very, very large and suitable for machine translation applications publicly available.
I'm sorry. I have a question. Is Moses playing dice? Is he like taking the probabilities as they come, or is he always taking the highest, the translation with the highest probability?
It depends what's actually going on in the inside, and I didn't go into a lot of these details because it's a little bit technical. You can check out the source code. But it ranks, it forms a lot of different hypotheses as to the best translation. And it does that by translating one phrase at a time, and it has a special stack of these hypotheses, and it ranks them as it adds on a new component, and then it picks the n best. So you can set n to be whatever. You could pick the top 5, the top 4. So that sort of it doesn't have as much of a random component as using the limiting. You don't want to. It's an exponential number of hypotheses, so you want to have a heuristic, and that heuristic might incorporate a bit of chance. A simple heuristic might be randomly pick a word and then only do this for 5 words and then pick the best. That would be a very stupid but simple heuristic. But essentially, it gradually forms the translation and can pick the best as you go. And at the very end, it can actually output, instead of one translation, you can have it output its top 20 picks. And you can sort of see, get an indication of how it's pruning out, how it's getting rid of some translations there.
Is 74 series glue logic? There's no...
I think I'm going to take one more question because I'm a little thirsty. 2 more? Okay, I can do
How
2 more.
do you handle faults like wrong spelling, wrong grammar, and so on?
Lots of data. So if you have a lot of data, most people are going to spell things correctly. That's why there is a correct spelling even. So if you have a lot of data, then the correct spelling will just win out. If you have a small corpus and you misspelled something simple like cat, then cat is always going to be misspelled in your translation. But really a lot of data corrects for that.
And can it handle wrong input data too for a translation? If the input data is wrong, how do you correct it?
So that's one of the parameters that you can play with. Out of the box, it just takes the input as is. So if you misspell something, then you're probably not going to get a very good translation. But it's pretty simple to add something into the script that automatically spell checks, that gets rid of certain words, suggests spellings, stuff like that.
Where do you see the limits of this system? How do you handle different concepts like having a dual in a language as opposed to singular and plural? Or another other example, what would you do in Hungarian with the wife of a king as opposed to a queen? Or what do you do with 7 expressions for snow?
So there are, in fact, fewer expressions for snow than we thought before, but in some languages there are a lot of different expressions for one. Again, data seems to be the answer, but there are limitations to this system. And really, I think the next level that machine translation is going to take is going to be incorporating statistics with some of the previous rule-based systems and kind of joining them into a new hybrid model.
I think it was last year when the Logos system has been released to the GPL license. And it's now called Open Logos. I think it's a rule-based system that has been established and built up during the last 30 years. Do you know if there have been already attempts to combine these systems?
Yes, there have. I can't reference those directly, but a simple way, one of my colleagues at MIT right now is that little pyramid I showed you before. She's using the output of Moses and then doing some tree syntactic transformations that are slightly rule-based, using automatically generated rules as well as human rules, and then further improving the translation quality. But that's really on the bleeding edge, so exciting things are to come, certainly. So I'd like to thank you guys today, and I look forward to the rest of the CCC, and again, thanks for putting up with the technical problems at the beginning. So.